Geotrig, lesson 1, day 3. Okay, so we're going to talk about triangles next. And to say that two items are congruent means that they are the same. I'm going to start speeding things up on here so that I don't have to wait. We should all have the outlines. Okay, what do? What do the three angles of a triangle add up to? 180. So all of the angles in a triangle, there are 3 of them, you should all add up to 180. So let's review the types of triangles. What kind of triangle is that one? And mark possibly what you know. That would not be a right triangle for sure. It looks like everything's the same. What kind of triangle is that? Equilateral. I don't know, is equilateral have an I in there, I think, is it? I think it's equilateral. Okay, so equilateral. It's an equilateral triangle. So let's put our tick marks on here to demonstrate what's the same and what's not the same. To be equilateral triangle, what does that mean? Everything is equal. No, a little more specific than that. All of the sides are the same. Tick mark, tick mark, tick mark. That's all the same. And all of the angles, come on now, angles are the same. So all the angles are the same. What kind of triangle is the second one? I don't know if I can claim that's a isosceles. A scalene. Ooh. Yeah, scalene.
Really?
Yeah, scalene means no sides are the same. Grace is pulling up triangles. She's using her resources again. That's no laughing matter. Or LOing matter. Okay. So, what do you know about this type? All sides, and angles are different. So things are different. There's nothing that's the same. It comes in handy to know some of these things. Next. Oh, it just copied over the other one. Let's go to the one on the bottom. That one. This one is a... Yeah, I think I just may have spelled that wrong. But it's a isosceles. I-S-O-S. Oh, I forgot my S. Oh, I was close. I'm going to erase that part. Now it's better. Isosceles triangle, and what do you know about this? 2 sides are the same, so we put tick marks on there, and what? 2 angles that are opposite those sides. What do I mean? That means that this side corresponds or opens from this angle. And since these sides are the same, the sides that correspond to those angles that correspond to those sides are also congruent. Very nice. So, let's use our idea that we should know how to solve this. Calculate the missing angles in the first problem. It looks like our side lengths are 10, 10, and it has an angle splitting them of 72. I'll give you guys a second or two to figure that out. What do we know about this triangle, guys? It's a special one. It's isosceles. So since these sides, the 10s are the same, that means that the angles opposite them are the same, right? So do you know what it is right now? Just off the top of your head, do you just know what it is? No, it's not told to us. So can I assign a variable to that? Could I call that x? But if I call that one x, I got to call the top one x? Is there a way that I could potentially build myself a little formula for this? What would that formula be? What do we know about triangles and angles? They equal 180. What equals 180? It would be 2x plus 72, or all of the angles. X plus 72 equals 180. Or 2x plus 72 equals 180. I want to see some form of equation that you guys have built so you can solve it. So essentially, 2x equals what?
Equals 108.
108. Divide by 2.
And that would be x equals 50 something.
54 degrees. Done. Hey, it's not too bad. Okay, let's talk about the second one. Calculate the missing angle measures. AKA, there's no angle measures except for one. What are you given there on the bottom? You know that this right here is 90. That's a box. So you know over here, I'm going to change colors. We'll use purple. 90, okay? So that's 90. That's all we're given. So now what are we going to do? Does anybody recognize anything? There's actually two things you might recognize on this one. It's an equilateral triangle on the big one, right? So that means all of the angles have to be what? The same. Well, how many angles are there? So that's 180 divided by 3, yeah? So that's 60 degrees. 60 degrees. That means this whole thing over here is 60 degrees. But look opposite that 60 degree on top, up here. I have an altitude being dropped all the way to the bottom. Split that into two equal pieces. So that means the angle opposite them is these angles right here on each side. Make up 60, but they are the same. Same. So therefore, each of them is congruent, or they are both 30. What kind of triangle is that? Does anybody know? No. In the small ones. The small ones. It's a right triangle, but what special right triangle is that? Scalene, correct. How about a 30, 60, 90 triangle? Has anybody heard of that before?
I have, but I don't.
We will be becoming very familiar with those this year. Take the time to open your book to page 24 and copy 17. So this is what the picture looks like. You need to solve for x and for y. So, which one's the easiest one to probably solve for here? X or y? I think x would be the easiest one. Why, Kevin?
Because it's on a
Straight angle, guys. Straight angles are how many degrees? 180. So what that means is that 35 plus x is equal to 180. Subtract 35. So x is equal to what?
X is equal to
145 degrees. Now, here's a cool thing, is the fact that, again, we have y, we have 4y, and 35 as my angles. It's the same variable and a constant. We know all three of those will add up to. You guys are scared. I'm going to say you're scaring me, guys. Plus 35 is 180.
180.
Wait a minute. If I subtract 35 over.
So we got 145.
Oh, and I can combine those, right?
So you get 5y.
Equals
145.
145.
35, yep.
And then you can divide by
Divide by 5.
5.
Oh, there you go.
So y is equal to?
90, no.
Not 90. Definitely not 90.
Just threw that one out.
20. 20, 29, and you're done. Okay, hey, wait guys. Is anybody making any other connection here between this particular problem and how we solve for x and a number that particularly pops up when we're solving for y? Well, 180. What happened here with x, the value of x, ended up being here. Guys, when we are dealing with this type of problem, the two other angles that are not associated directly with the angle on the outside are actually the same size as the angle on the outside. So the y and 4y is the same as x. They always will be. Doesn't matter what size triangle you have. I can't think off the top of my head. There's a name for that. I'll have to look that up. Grace? Look that up. So Grace looked it up. It is the exterior angle theorem that says that the angle on the outside is the same as the angles on the inside, the remote angle. I think the remote angles. The remote angle on the outside is the same as the two interior ones. Next one, area and perimeter of a triangle. How do we calculate the area of a triangle?
You add up all the, no, I'm sorry.
What's the area of a triangle? Everyone should know this. Not just Jake. Base times height divided by 2, or a lot of us will say 1/2 base times height. What does area tell us? Basically, what is area? It tells us the 2D space it takes up, right? 2-dimensional space. Volume would be a 3-dimensional space, or area, right? Or volume. How much it takes up in 2D. Perimeter is the blank of the shape. The outside. That would be fine. The outside distance, maybe? I don't know. The distance all the way around. The synonym for height is, I actually used this already today. Altitude. Altitude. I think there should be an I in there someplace. Altitude? I don't know. I'm a horrible speller, guys. Sorry. Height of a triangle is the altitude. Okay? So when you're taking an altitude of a triangle, you're taking from the highest point down to the basement of the floor that is level with the floor. Okay. Example 4, an equilateral triangle. You guys, when I start to say an equilateral triangle, your mind is already picturing an ideal equilateral triangle. Has a perimeter of 24 meters, and it has an area of 16 square root of 3 meters squared. Find the altitude, aka the height. So, that ideal equilateral triangle needs to be drawn, people. Boom, boom, boom. That is, of course, an ideal equilateral triangle, yes? And we know that there's going to be an altitude or a height component. And that height component will be perpendicular to the ground. That's h. We need to find h. We know that P, perimeter, is 24. Area is equal to 16 square root of 3. How can I put those together to figure out an answer? Again, these are not just plug in this number, get an answer out type problems. You have to work for these. You have to put things together. So, using perimeter, what can I gather from that? Each side will equal a value of 8. Yeah. Okay. Very nice. So we use perimeter up. We probably don't need to use that anymore. So maybe let's use the other piece of information, which was the area. What components do I need for area? Base and height. Ooh. Well, I already have area itself. Do I have a base?
No.
Yes, it's on the bottom. Do I have a height? No, but it's asking us to find that height. So that means this is how to be equal to 1/2 times the base times height. Can everybody see that? 1/2 base times height should end up being 18 square root of 3. Can you solve for h? I hope so. What's half of h? So 16 square root of 3 equals 4h. Get rid of 4 times h. I will divide by 4. What's 16 divided by 4? So it's 4 square root 3, because square root of 3 didn't go anywhere, equals h. And of course, I should put a label on that. It's 4 square root of 3 meters, not meters squared. I'm talking about a distance or a height. So it won't be squared, it's a linear measurement. So it's 4 square root of 3 meters. Done. Not a straightforward problem. That's what this book is full of. That's why kids get scared. Don't get scared. Think. Next is transversals, alternate and corresponding angles. A blank is a line that cuts or intersects a line, one or more lines in the same plane. It's in the name, guys. Hey, there we go. Transversal. So a transversal is something that cuts. So on here, T, line T, is a transversal. It is cutting one or more lines. If the blank cuts through parallel lines, transversal. If the transversal cuts through parallel lines, blank and blank angles are formed. Well, actually, it's not the other half of that name. It was close. Well, take a look, just to look at what the kind of angles are being formed. Like 1. What kind of angle is 1? Obtuse and that's not obtuse. Obtuse and acute. Acute angles are formed. Maybe that's not. Maybe that wasn't it. Maybe it might be. Maybe it's the not only obtuse and acute. It could be right. So maybe this is not the right one. Maybe we want to say exterior and interior. How about that? Sometimes there's angles inside the parallel lines, which would be 4, 3, 5, and 6. They're inside. And then sometimes you got ones outside, which is 1, 2, 8, and 7. Interior, exterior. Now, looking at your diagram here, can you make any assumptions about angle measures? What do you think you can assume here? What looks to be something? You should know some of them already, because we talked about it yesterday. Like 1 and 3. 1 and 3 are the same. Why? Vertical angles. They're vertical angles. That means 2 and 4 are the same because they're vertical angles. 5 and 7?
Vertical.
6 and 8?
Vertical.
5 and 6?
Horizontal.
Yeah, we don't have that. I was hoping someone would say vertical because you're not paying attention. Okay. No. Yes. All the ones that we listed there, except for the last one, are vertical angles. By definition, they are the same. But look at 3 and look at 5. Don't they look the same? Doesn't 4 and 6 look the same? Because they are. And so what happens is that you get this zigzag pattern of congruency. 2, 4, 6, 8 are all the same.
Oh, 1, 3, 5, 7.
And I'm going to go back, change back to green, and say 1, 3, 5, and 7 are all the same. So on the bottom it says examples 3 and 6 are called,
3, 6 are...
those are the names above. Actually not. Those are 3 and 6. This one is consecutive. Consecutive angles, where 3 and 5 are called, 2 words, alternate, and they're inside, so interior angles. And then 2 and 8 would be 2 words. What? 2 and 8, opposite sides, alternate, exterior. Corresponding needs on the next page.
What page is it? Same page?
This is the same page on page 24.
Oh.
No, sorry.
What?
Hold on. All right, this is the correct one, page 12, 15 through 21, 24 through 25. Have a fantastic day.